Hi everyone, welcome. Thank you all for joining me today, and good morning, at least good morning from California, Oakland, California, where I'm tuning in from my home. Good afternoon, good evening to all of you who are joining from across the world. I am just going to get started in a moment. I'm taking just a quick minute to read through the chat for right now. So at Bo Frank, yes, just to confirm, this will use the Azure Blockchain Development Kit. So I'm going to be going through that in detail and highlighting all of the different things that you can do with the Azure Blockchain Development Kit. Even though you can't really tell that from the title, that is what I'm going to be doing. I'll show the agenda in just one moment. I will call out that this is a kind of continuation from this session that I did the other day, where I'm going to be kind of building on that example and kind of getting more hands-on into building out a series of smart contracts. Then I'm going to focus on deploying and first also viewing our blockchain on the Ganache Ui. So I'm going to use some different tools than I used in the last session, just to kind of highlight some more of the options that you have when you are developing your own smart contracts. I want to definitely provide some exposure to that, as well as, again, all the things that you can do with the blockchain development kit for Ethereum. And then I'm going to also spend some time on deploying to the cloud and talking about some different options for that and showing those off as well. So that is the basic overview for now. I guess just a quick introduction for me. I don't know if folks have been on streams before or seen me, so I'll make it quick, but my name is Meaghan Lewis. I'm part of the Microsoft Reactor content team. And what is interesting to know, I've been streaming for about 2 months now, so I'm still kind of a newbie at this. You might have seen me talk about some topics like Python or machine learning in the past. I'm super excited to be getting into some more blockchain content now. This is something that I've been really excited about since I joined Microsoft in late 2019. So I've been working on some new blockchain content. So this is just kind of exciting for me to get to share some of this content and share what I've learned so far. I'm not an expert, definitely still a lot to learn, but it's been super fun kind of just exploring some of these different topics and just becoming more knowledgeable about everything. So this is now our second official stream on blockchain content, but I'm hoping to do a lot more and would love to hear if there are other topics that y'all want to cover that we aren't covering today. So that's kind of the rundown. Again, the goal of today is going to really be to get more comfortable writing, testing, and deploying smart contracts. We talked a little bit in the last session about what these smart contracts are and why they're important. And that is because we're really, stepping away from, or maybe moving forward from cryptocurrency, right? Where we have these smart contracts, which are a set of functions that can describe rules for how we want to transact with other folks and transfer digital assets. So we really don't have to just focus on cryptocurrency as examples. We can focus on any kind of transferring of digital assets. And it's been really exciting to kind of just see how smart contracts are now evolving and kind of thinking about, different applications where you can use smart contracts in all the different industries where you can use smart contracts, whether you're thinking about, banking, healthcare, public records, private records, supply chain examples, voting, gaming, which is kind of what we're going to be looking into today. So there's just a ton of different practical examples that you can actually start to apply when you're writing these smart contracts and kind of building applications around them. So we're going to focus on the smart contract bit, not the whole building applications bit, but I'd love to do that in the future. So let me now share the agenda. So I've talked through this a little bit, but I'm just kind of reinforcing, especially as folks are still joining, that this is what I'm going to be covering. So I kind of gave the overview of today. I'm going to start just by highlighting some different tools that we're going to be using during the stream today, as well as just other tools that would be helpful to know about and also just to explore on your own and maybe use later. I'm going to be spending a good chunk of time kind of in the middle section here around using the Blockchain Development Kit, building and testing smart contracts, deploying locally, and then deploying to the cloud. And then I'll just try to save some time at the end for Q&A. But of course, Q&A is always welcomed throughout the entire session. I'll be monitoring the chat kind of down here to my right. And then my wonderful teammate, Dr. Guthel, Sarah, is in the chat as well. So if I am not paying attention, she can kind of step in and provide some information as well. So that is the basics of today. I guess now let me switch over to my browser. And I have that link on the screen right below where you can see where to find the demo at. This is the same link where we've been putting all of our Reactor online content at aka.ms/reactors_online. So I am in the blockchain directory and then the build smart contracts directory. So I would start with the README, of course, just to kind of get a better understanding of what's happening here. So I just outlined first the prereqs to complete the demo. So I'm going to be using VS Code, pretty much like I always use VS Code. For these contracts, the Node Package Manager and Node.js is required. I think that's a typo, sorry, NPM. And then also to develop, test, and deploy the contracts, I'm going to be using Truffle. Again, I can talk a little bit about what Truffle is. I'm also going to be using Ganache, and this time I'm going to be using the Ganache Ui. Last time we used the CLI version. And then we're going to be going into the Blockchain Development Kit. So before I move on, let's talk a little bit more about Truffle in particular. So if you're not familiar and maybe just didn't catch the last session, that's totally fine. Truffle is what we're going to use to help us develop our contracts in Ethereum. Truffle provides a really nice set of tools to kind of make development easier. So if you do not have Truffle, you would need to install it like that. Npm Install Truffle-G would be the way to do that. So let me navigate over to here. Okay, so yeah, I'll showcase Truffle, but basically it's going to allow us to compile, migrate, test our contracts, do things like that. And then I'm going to be using Ganache. And so for Ganache, the best way to do it is to download. So if you go to trufflesuite.com/Ganache, you should see a button similar to how I see here, with your appropriate operating system listed there to go ahead and download. And Ganache is really, really slick. I really enjoy using this tool so far. It's really easy to start up, basically your own personal Ethereum blockchain with a default set of accounts with some test ether. It allows you to see all of the transactions, the events, see some more details about your contract, all within the context of this UI. So that's a really cool tool as well that I wanted to highlight. And yeah, I'll talk about the Blockchain Development Kit in just a minute, probably when I transition to VS Code, but I did want to call out one other thing. And something that I was kind of just getting a little bit more exposure to recently is this Remix IDE. So with the Remix IDE, you can actually use this to develop and kind of run and test smart contracts as well. So if you go, I can post the link to this as well. Oh, thanks, Sarah. So this is a cool option if you don't necessarily want to download some of these extra tools. Like, this is probably a good way to get started if you just want something quick and easy and in the cloud that you can go and run and kind of explore these different contracts. And just by default, they have just a set of different contracts here for you to come and explore a little bit more. So I definitely recommend that. And then I feel like there's one more thing that I want to show at least before we get started. I'm trying to remember what that is. Oh, okay, yeah, I remember. So let's see. The last thing, at least for now, would be the Solidity site, at least the documentation. I posted the link to that there. So I think between kind of the truffle sweat, the words truffle sweat, I can't say that still. You get it. The Solidity website also has a lot of really helpful information. I kind of showed this last time, but Solidity is the programming language that we're going to be using to actually code these smart contracts in. It is the kind of official programming language for Ethereum. So just to learn a little bit more, I definitely recommend checking this site out. I find that I'm kind of always coming back here and kind of referring to the documentation, learning a little bit more about, you know, the syntax and trying to understand all that really clearly. So I definitely recommend to come here as well and check all of that out. In addition to the tutorials that you can find on trufflesuite.com. There's actually a lot of really cool information here as well, and really in-depth tutorials that will kind of go into integration with lots of other tools, like Zeppelin, which we'll talk about in a little bit, building a DApp, a decentralized app, kind of a UI around your app. And so there's just really cool things here as well that I would also recommend checking out just for further learning. So I think that is probably about it that I want to cover as far as an overview for now. So probably let me go ahead and jump into the editor. So I already have VS Code open up for now, and I'm just going to start at the welcome screen. And I want to just show the process actually of going ahead and installing the extension. I just uninstalled it, but if you go over to the panel on this left-hand side, you can get to the extensions. And here you can find the Blockchain Development Kit for Ethereum. So I think the first thing to call out probably, and this was in the README as well, but just the different system requirements that you're going to need for using the Blockchain Development Kit. I think outside of the dependencies that I explicitly mentioned, you also just need to make sure that you have some version of Python, at least 2.7.15, and then a version of Get as well. So those are kind of the requirements that you need to get started. What's nice is that after you actually do install this extension, and let me install it now, and you'll find it's pretty quick. Also, apologies if you hear any banging in the back from construction. So yes, it's pretty quick to install, and it will let you know if you don't have any matching requirements or some missing requirements perhaps. It's definitely going to let you know. So don't have to worry about that for now at least. I guess let me just quickly walk through this. So you can do a bunch of different tasks with the extension here, getting started with smart contracts. So in the last session, we did some of this, at least kind of creating a new smart contract project through Truffle init. In just a moment, I'll do that same action, creating a new smart contract project through the extension. You can also deploy to Truffle Ganache locally, which is what we're going to do today. You can also deploy with Infura to Ethereum mainnet and testnet. So this is going to allow us to do some cloud deployment of our contracts to this Infura network. Infura is a very popular Ethereum network where lots of other folks actually host their applications. So we'll talk a little bit more about that in a bit. And see how we can deploy there. You can also deploy with the Hyperledger Basio. I think someone had asked about that the other day. I'm not going to get into this later, but maybe that's a future session. And then we are going to be deploying with Azure Blockchain Service to the cloud as well. Sorry. So I'll go through what that looks like. And for most of these other actions, you don't need to have an Azure account to do most of this, at least to do anything locally. But when we think about actually deploying to the Azure Blockchain Service, we are going to need an Azure account. So that is not something that you have to do. I'll definitely walk through it, but just to let you know, that is kind of where you would actually need to have an Azure account. And I'll talk a little bit about the cost for this service too, just to make that clear. So yeah, I think that is about all the overview for now. So let's go ahead and actually get started with creating a new Solidity project. It is still a little bit early for me, so words are hard right now. I need to drink some more coffee. Okay, so yes, I'm going to start with creating a new Solidity project using the Blockchain Development Kit. So one thing to call out is I can do Command-Shift-P, which will bring up the command palette for VS Code. Very useful tip if you use VS Code often. So you'll see that just to get started with, there are a few different different commands that are available. And if I just type blockchain, I can see all of the others that are available to me. So I'm going to pretty much try to walk through all of these options if I can, but let's just start with the top one for now. And I see sometimes it'll look like nothing is happening. There was some information on my bottom toolbar here down below, but now it does ask me up in kind of the header if I want to create a basic project or create a project from a Truffle box. So I encourage you to try out both options. They just basically give you a different set of items to get started with. So with a basic project, we're just going to get an example contract, migration, test. Creating a project from Truffle box is going to give us actually a little bit more than that. It gives us like a couple contracts and migrations and stuff. So let me go ahead and create a new directory for this. Oops. So I am going to get prompted that I need to use an empty directory, which I thought I was trying to create. Maybe from here I want to do new folder. Okay, so let's create a new Solidity project, and I'm just going to create this new directory with nothing in it, and then we'll see what happens in a moment. See down here that the project is creating. And sometimes it's helpful to do things like open up the output, because sometimes tasks just take a moment to complete. So I can kind of open this up in the background to see what's happening here. And I do see some output here that we are preparing to download box, and basically the box is going to give me kind of a set of different items to actually get started really easily with writing more contracts. So then I see that it was downloading, and it doesn't appear to be done, but I think it actually is done. And you see in the bottom right here, I think my face is kind of covering it, but there is a message here that says the required app is not installed or has an older version. So if I click on the details for that, I do get a notification here. Like I mentioned, don't worry necessarily about installing all of these things, because if you don't have the right versions, the extension will let you know. So here it's complaining about my version of Node.js, which I definitely have a version of Node.js. It's just not quite liking this version. So typically I'll see this, and I don't know if I want to install another version of Node.js, so I might honestly ignore this for now and kind of see if I run into problems later. That's kind of how I handle these things sometimes, because I know I have a version of Node.js that is at least greater than this. So for now, I'm probably gonna just leave that off to the side. And let's go into our new Solidity project. So in my workspace over here on the left-hand side, I see all of the different items that were created from this Truffle box. So I have the contracts, like I mentioned, so a couple different contracts just to get me started, migrations, I have a test file, and then it also does some nice things, kind of just creates some additional MD files. So I already have like a changelog, contributing license. I have a package.json, which is going to allow me to really easily add new dependencies that I'm using, new node packages and things, and as well as this Truffle Config.js. So this is a little bit different than if I was just using Truffle init to go ahead and create a new project. Here I'm explicitly using the Blockchain Development Kit. With Truffle init, you get some of this. You at least get kind of that migrations contract, your initial migration. You don't have any kind of initial test. You don't have any of these other files. So you get a little bit more with the Blockchain Development Kit, which I like. I think it is helpful, especially because I'm likely going to want to add more dependencies. Like for example, this Truffle HD wallet provider is likely going to be a dependency when I think about, deploying to the cloud or other places. I'm actually going to have some kind of wallet, which is going to store my public keys and my private keys. So it's kind of nice to kind of have everything I need for now set up. So if I right click on this file, I'm just right clicking on a simple solution, the hello blockchain.solidity file over here. There are some options that I get as part of this contract. So the first thing that I can do is just select to build the contracts. And I see that it's building. There's a little banner in my bottom right. I guess y'all can't see that, but I can look at the output and you should at least be able to see most of that. Okay. So I was just letting it finish a little bit. I think the command is finished now. There is one problem up here that is important to talk about because I've seen this happening, in that I'm getting an error up at the top of this contract that the source file requires a different compiler version. Note that the current compiler version for Solidity is 0.6.8. So that is good to know. And I'm just using greater than 5.0. So I can do something like where I want Solidity to actually be greater than or equal to 5.0 and be like less than 7.0. And that should be better. So here I'm kind of just defining a range for the version of Solidity that I want to compile against, which seems to fix the problem. I think, you have to also consider that when you're locally developing that you might, be using a different version of Solidity than you can be, deploying to in the cloud, like Infura or Azure Blockchain Service. So sometimes it's nice to just provide a range. I've noticed that even if something works locally at 0.6.8, if I do deploy it to Azure Blockchain Service, I could get a problem there because maybe they're using an earlier version of the Solidity compiler. So just a helpful tip to know that. So after I have built the contracts, I can go ahead and deploy them. And so when I choose to deploy here, I get a variety of options. So for now, let's go ahead and just try out the local development. And I see a banner that my contracts are deploying. I should see some more output here actually in the window. We started migrations. It ran that initial migration. I see that some things are happening. This migration created a new block. Timestamp, I can see the account that it's using, which should just be the very first account that I have on my Ganache client. I have a balance of Ether here, and I see that for this transaction, we use a very slight amount of Ether. And I kind of see the same thing as we deploy the second contract. Cool. So I like to just scroll through that information. I think all of this is really helpful just to kind of get, and I can make some of that bigger. I don't know how big it actually is. There we go. So I like that you can just kind of see all of this information here I feel like this is super helpful, especially when you think about, you know, the fundamentals of blockchain. Basically, with everything that you're doing, even, you know, as you're developing your own blockchain, you're kind of seeing how transactions are added to the chain. So I'm kind of just adding new blocks just by running these migrations and such, and I can see the different data that is sent along with it, and know that this is like always going to be a part of my blockchain, that, you know, there is this transparency in which I, you know, every action basically is tracked in my blockchain. So that's just kind of cool to understand that. So after deploying, I want to check out showing the smart contract interaction page. And right now it's trying to load the DApp, the decentralized app. And I'm going to be honest, sometimes this does not always work, but it's really cool when it does work and we can see it. And at some point, we definitely will see this today. So I might just have to come back to it. But the smart contract UI is really cool. It provides at least a simple UI and DApp for us to actually interact with the contract in some way. So if I go over to the contract, actually, you'll see that there are a couple different functions, I think. So there is the send request function where you can just send some kind of request message. And then there's the send response function where you get some kind of response message back. So the smart contract UI is really nice because it allows us to actually try out these functions and basically call these functions and then trigger events to be added to our blockchain. So it's really cool to be able to see that. And yeah, can't right now, but we definitely will later. I'm going to get this to work. I feel like there is a key. But just so you know, if you are trying this, you are not alone. If this is happening to you, this sometimes happens to me. Sometimes I just have to restart VS Code, or I kind of just keep trying. I'm persistent. All right, it's not working for now. So I think before I move on, let me at least try to get into this option here around adding contracts from Open Zeppelin. So I do want to highlight this. We're not going to get into it so much today, but essentially we can use Open Zeppelin. Open Zeppelin provides a lot of secure contracts, like kind of pre-built contracts for us to incorporate into our own contracts. So there are a lot of contracts that just implement very common tasks. So what would be a good one to use? I mean, honestly, any, but especially like maybe the tokens, for example. And maybe I can try to download this so we can see an example, but there are a bunch of helpful pre-built, verified, secure, tested contracts that you can get through using Open Zeppelin. And the extension that we're using makes it pretty easy to actually get these contracts into your own workspace directly. There's also a SDK that you can use on Open Zeppelin. We can check that out in a moment. But there is just some helpful things here. Maybe we can start with the access and roles. So the other day we had this mentor role who can be the one to actually create some kind of coin, crypto coin. So it's nice to actually be able to kind of use some of this pre-built code that is trusted, again, to integrate into your application. So you can see here, there's just a bunch of different functions that you can have around the mentor role, which is a pretty common role when you're thinking about contracts, smart contracts, and actually having some kind of role that can create new coin or some kind of test crypto or something for you. So there's just some helpful things in here that I definitely wanted to call out. I think the token code is also pretty helpful. There are the different protocols for tokens that we have here. I think this is just highlighting the ERC20 token, but here there's also a lot of great tools that can allow you to interact with your different accounts, like get balances, transfer money, approve purchases and things. So again, all of this is super helpful, I think, to learn how to integrate into your contracts. I'm not really going to do it now. It kind of is a little bit involved, and I just kind of take the route of at least just writing contracts from scratch for now, but I think that definitely is the way to go when you're thinking about kind of writing more production and level contracts. So let me see what else there is to show, at least about the extension for now. See if this page comes up. Okay, nope. Cool. There is also a tab at the kind of bottom left of my screen where you can see blockchain networks here. So right now I just have a local service, but I can have different services for Infura or Azure Blockchain service, like I mentioned below. So it's just nice to easily see all the networks here that I'm available to deploy to. It's also easy here to go and connect to a network, to create a new web network, and so on. So I'll demo that in a little bit later, but I think this is probably it that I want to show with the extension for now. And next I'm going to jump into actually getting into building out some more contracts, kind of building on the example that I showed in the last session, and we're going to write a couple more contracts and a couple more tests and then bring that all together. So I do see a comment down here from Coxeye Guy about one of the common challenges that I've run into when using Solidity or any other development platform currently associated with blockchain. There's always something which isn't quite aligned with the latest version, and so things just break. Yeah, I can definitely understand that and relate to that. Just like I explained about, using the right Solidity compiler version, or rather using a range. I feel like even with a lot of these tools, right, like what I showed with the Azure Blockchain Development Kit and kind of needing to have specific versions of tools. Like, I feel like with so many tools and dependencies, you're always going to be having to make sure that you're using the right version of different tools. So yes, I think that's about much of the overview that I want to do now. And let me switch over back to my browser momentarily. Cool. So one thing that I want to show here, and I'll just go ahead and link to that I didn't before, if you want to learn more about Open Zeppelin, I think it's really cool, and I would encourage you to do that. We could definitely do a future stream about incorporating some Open Zeppelin contracts and functions into your own contracts, but there is a bunch that you can learn here, even just by going to the docs, different examples and tutorials that you can go through to get you a little bit more comfortable with some of this stuff. So let me close some of these tabs. I am going to start walking through the example now. Like I mentioned, you can find all the code here, contracts, migrations, test, and so on. So I'm going to start walking through that and just go ahead and set up a new VS Code project kind of in the background. So just give me one moment. I'm also going to take a quick coffee break. At Fragrance Free Vaseline, thank you, and we are happy that you're here. All right, I'm almost about ready. So let me switch back over to VS Code, and let's go ahead and I'm going to create, I guess I'm going to create another new Solidity project. Let's start with that. Okay, but I am getting some kind of problem about my Node.js version, so maybe it's not going to allow me to do that right now. So let me go ahead and try to download this version and see if that makes a difference. It is strange because it did just let me create a new Solidity project, right? I think y'all barely see that error down in the bottom right hand of my corner, but to run this command, you should install the required apps. Please see the details on the requirements page. And also just to confirm, I do have a Node version 12.14.0, which looks like it's pretty close to the current version, which is 12.17. So let me see if I do download that, if it actually makes a difference. One moment. Feel free to ask more questions in the meantime while I'm trying to poke around and get this working a little bit more. All right, install. And is anyone else installing the extension now and running into similar problems? We can talk through those too. All right, it is doing some installation in the back, still kind of doing stuff. But just to confirm, I still cannot create a new project. Okay. Right. When I open the output, I do get a bunch of different errors here. Get version for required apps, node, npm, and get. So there is some kind of problem there. All right. And let me go back over to the extension page. Sometimes it's helpful if you go to the extension page. Sometimes I just like to look through the settings. There might not be really helpful things here, but sometimes you can actually like set very specific paths to all of the versions of the tools that you're using, like Node and like Get, Python, all of those different tools that you need. All right, this is not working for me. So in that case, we're gonna do something a little bit different. So I'm gonna open up my terminal here. Hopefully y'all can see that okay. And let's go ahead and see what directory I'm in. Okay, so I'm in just my root directory. So I'm gonna go ahead and cd to projects. And from here, I'm gonna make a new directory that I'm gonna call Blockopoly. And let's go ahead and cd to that directory. Okay, and then once I'm here, at this point, what I'm going to start by doing is just a truffle init. So before I do that, let me just run truffle. And there you can see all of the list of commands that are available with truffle, like building, compiling, init, which is going to initialize that new empty project for me, migrate, test, and so on. So I'm going to just do a truffle init, primarily, honestly, because I'm having problems with my extension right now, it appears. But it's okay. We will still be able to use the extension later on. So truffle init within this directory, within a new empty directory, is basically just going to do a lot of the similar things that it did before with using the blockchain development toolkit. But I'll point out the differences again in just one moment. So I do need to go ahead and switch over to that new workspace. So let me open this new project that I just created. Okay, so here we are in my new directory where I have kind of the same structure as before, but a little bit less, right? When I did use the blockchain development kit, I got those extra files like the changelog, the contributing.md markdown, the license, a package.json, and all that. So I'm going to have to kind of recreate that here, but it's okay. It's good to, again, just kind of know the differences and how you can create these different Ethereum projects. So I should first introduce kind of the smart contracts that I'm going to be building probably for the next 30 or 40 minutes. I did mention that this was an extension of the contract that we created the other day. So if I actually go over to my browser one more time and we look at the contracts, so there are going to be these primarily 3 contracts that I'm building out. First is going to be the bank, which I referred to the other day as the coin. So what I'm kind of building off of here is this example, this game example, and it's really kind of a riff off of Monopoly, which is why I called this Blockopoly. And so this is kind of a project that I've been working on here, where I think Monopoly, or rather Blockopoly, could be a really good example for kind of seeing a blockchain in action through the use of a game, and understanding how transfer of assets work in a game like Blockopoly, where you can do things like, you know, buy properties, you can do things like pay other players for landing on their properties and things like that. So the other day, what we did in the last session was create this contract called Coin, which essentially had all the same contents here. So let me go ahead and copy this and actually put it in the editor, because I think it'll be easier to see that way. And then I'm going to write all the other contracts kind of as we go along and explain all the pieces there. So going back over to VS Code, what I'm going to do is right click to create a new file. And I'm going to call this bank.sol for Solidity. And I'm going to go ahead and just paste this code in here. And let's go ahead and start back up at the top. And I'm going to try to explain all of this for those of you that weren't familiar with the contract that we created the other day. But what it starts out by doing is, like we saw in the other contract, defining the version of Solidity that we want to compile against, define the name for the contract, which is bank in this situation. Here I am defining a new state variable of type address. So that is going to be one of the account addresses to represent one account or one individual that we have on our blockchain. They are going to be called a minter, and so they're going to be allowed to create currency. Then I'm going to create this mapping here between our addresses and some unsigned integer. And this is going to be a mapping of balances. So essentially for a balance address that I provide, for an account address that I provide, I can get their balance back as an integer. Then there are events that we can go ahead and define, and events are going to be output in our blockchain, basically. So when I call the sent function, it's going to, you'll see it's actually going to emit this sent event, so I can see that very clearly, who I sent money to, who it's from, and the amount that was sent. This constructor code here is going to be called when the contract is created. So here it's going to basically assign the role of minter as the one sending the messages here. Basically, they're the ones kind of doing all the action in this contract. Next, I just have two different functions in here. So for the mint function, there's going to be a receiver and an amount. And this is also a public contract, which means that I can use this contract within other contracts, or this function rather within other contracts. So we'll see that as well in just a little bit when I get to writing these other contracts. I think another key part of Solidity is these require statements. So here I can require that, again, the message sender is equal to the minter, and that only the minter is allowed to create this new coin. Require the amount is not out of control. And then here I can basically transfer some kind of balance to the receiver whose address I specify. Then there is the send money function, which basically does like it says, but you specify the address of a receiver, a sender, an amount. This is also a publicly modified function. I have a couple of different requirements here that basically only allow the minter, again, to authorize transfers to different accounts, and also require that the amount available, that they have the right amount available to actually send money. Then we do some different actions here to decrement the amount from the sender to add the amount to the receiver. We emit that sent event that I had shown earlier. So here we would actually see that event in our blockchain. And then lastly, so I think all of this that was that I talked about was what I coded in the last session. The only thing that I did right now was add this get balance function. So for this get balance function, all you have to do is specify the address for an account, and then you can see the account, the balance for that address. Cool, so that's basically all that we're defining here. So this is the bank contract. I'm gonna move on to define both an asset manager and also a banker. So I should talk a little bit more about what those mean, and just pose some questions for y'all. So hopefully this becomes a little bit clearer, but one sec. Okay, so I meant to show this first, but again, I'm gonna focus on kind of building out this game, Blockopoly. We're kind of only gonna get to build some of the basic rules for today, but I think it's important when you're thinking about building any kind of application and when you're ready to kind of write your smart contracts to think about what are all the different roles and behavior that you want to enforce in your application. So as I have been thinking about this game, there is just some questions that come to mind, like what kind of roles do we need? So in this Blockopoly game, we're going to have a couple different types of roles. We're going to have the banker, who is also the mentor, who I kind of talked about a little bit. And we're also going to have players that are allowed to join the game. So I think typically in Monopoly, there are just players, and one player has kind of the extra role as a banker. But here we're just going to designate one of our accounts on our blockchain to actually be the banker. Another question is just what kind of game behavior is there? So kind of the same in Monopoly to some extent. We are going to, allow people to join the game. We're going to allow people to do things like buy properties and pay other players, like I said. What gets transferred? Properties, money. I think that's kind of the same answer there. How do we identify players in this game? We're going to identify players, of course, through some kind of piece that represents them. We're not going to be using kind of the traditional Monopoly pieces. Here, we're going to be using pieces that are all named after cryptocurrencies. And we're also going to be defining a set of properties that we can purchase that are going to be named after all of our Microsoft Reactors. So that's kind of a little bit more info there about just how we identify players and how we'll identify properties. And then the last question is, who do we trust? And the answer here is really no one. I think in a traditional game of Monopoly, Blockopoly, whatever it is, at least when I play it, I'm not really trusting anyone else in the game. I probably have only completed a game of Monopoly successfully like 4 times before someone has like cheated and ruined the game. So I think what's nice about building out this game building out this game on the Ethereum blockchain, we're going to enforce a bunch of rules, and we're only going to get to touch like some of those rules today and some of the gameplay today. But the idea is to really build in all of these rules and requirements into our contract so that everyone that joins the game and participates in our own blockchain network has to follow the rules, right? So kind of helps again to enforce some of those blockchain concepts. Cool. I hope that makes sense, and that was kind of a useful sidebar, but I think the important thing here is just when you're thinking about developing an application, really stop and ask these questions and kind of to think about how you are going to enforce behaviors in your game. All right, so going back now, I do have this bank contract. Similarly, I should go ahead and also add a test for that. So the tests are written in JavaScript, and I'm just going to create this new JavaScript file. And in the background, I'm just going to copy over the test that I had created previously in the last session. So hold, please. All right. So with this test, it's pretty much a simple test for now. I'm basically just using the bank contract. I'm using this Truffle assertions library. And what I'm doing here is basically writing some simple tests to test out that mint function, the send money function to assert that my event of sent was emitted. There's also just a series of different tests here to go ahead and get the balance. So just testing out that other function and kind of checking some of the rules here. So it's kind of just a basic test. I think that there can still be a lot added to this, and we can do some of that testing of actions that aren't allowed a little bit more than what we've done here. But this is kind of the basic test for now. And you can definitely look through this more and feel free to add your own test. So the next thing that I'm going to focus on doing is, let's go ahead and add a new file. And I'm going to call this asset managers. So now I'm going to focus on actually building out this asset manager solution. And feel free to keep asking questions too. I'm monitoring. I think it's been a little bit quiet. Yeah, let me just take another look there. Okay, cool. So let's go ahead and start building this out. I'm going to just start with that pragma definition. It's greater than or equal to 0.5.0 and is less than 0.7.0. And then I'm going to define my contract name. And in here, I'm going to define a new state variable of type address. This is going to be a public variable called manager. And then what I'm going to do is define a new struct. So this is a very common data type that is used with the Solidity programming language. If you are familiar with other programming languages, you're familiar with structs and how they work. But for this asset, so for an asset here, we're talking about things like, at this point, just a property, right? We want to define things about that asset, attributes about that asset. So we're going to have an owner. We're going to have a name for that asset. So it can be like the property name, for example. We're going to have an unsigned integer of a price. And then we're going to have two Boolean variables that are going to allow us to see if this property is owned and whether or not it exists. So that's kind of our basic struct. We're also going to have a mapping here between an unsigned integer and an asset. And then I can define this as public assets. So we're just creating this mapping here, similar to how you saw in the last contract where we have these assets. So for a particular asset number or unsigned integer, we can get that asset back. So we can get information about the asset back that we are going to be using later. Then I'm going to define a couple different events. So the main things that we're doing in this contract are focusing on events for assets that are added and events for assets that are transferred. Cool. And then within this, we want to have some different parameters. So we're going to have a sender, a name of the asset, and a string of asset type. Let me go ahead and close this. And then similarly for transferring an asset, we're going to have a sender address. We're going to have a from address, a to address, a name, and then a string asset type. So there are just some additional parameters that I'm defining here. And we have a sender, a from, and a to. The asset manager basically is going to be the one who is allowed to facilitate these transfers. So that's basically our banker. So the sender should always be the one facilitating this transfer, and then we would have a from and to address additionally outside of that. And all of this will probably make a little bit more sense as I keep adding the code here. So I'm next going to just define a constructor and a couple other functions where we can actually do the asset adding and the asset transferring. So just a few other things that I want to do in this contract class. Constructor. And this is going to be a public constructor that is going to be called when this contract is created. So here I'm going to define a manager. And next, I'm going to just define those two functions that I was discussing. So there's going to be a function to add an asset. And then similar, there's going to be a function to transfer our asset. Cool. So I'm just kind of outlining those. It's going to be upset and complaining about the errors here. So first, what I'm going to do is define all the parameters that I need to pass in to actually be able to add an asset. So I'm going to pass in a string of memory, and it's going to need the name. And I'm basically just adding this underscore here to kind of distinguish from this name, and you'll see more of that in a moment. Asset type. Then I'm going to also be expecting the price and the owner, I think, should be the only other things. So the unsigned integer of price. Make that a little bit smaller for now. And then I'm going to need the address of an owner who is going to own that property. And this is also going to be a public function so that we can use it in the next contract that we're going to write. So here I'm just going to add a quick requirement to ensure that only the asset manager can go ahead and add these assets. And then add a message if someone outside of the asset manager or the banker is adding these assets. All right. So next I'm going to define this variable called asset ID, in which I can get the ID of this asset and then be able to assign it correctly to a new owner. So I'm defining this new unsigned integer, and I'm going to be introducing this Keka K256, which is the type of cryptographic hash that the Ethereum networks uses. So basically, I'm just adding some extra security here around the asset ID so that there is some security there and that no one can figure out the asset ID very easily. So to get that asset ID, I can just pass in the name and the asset type. So this is going to be something like the name of the property, and the asset type is the property in this case. And just, I'm making this kind of general, like about asset types, because there can possibly be other types of assets that we want to transfer in the future outside of properties. Maybe we can think of a world in the future where we might transfer things like our player pieces or something else, but there might be some other type of asset transfer in the future. All right, so next I'm going to add a requirement here just to specify that the asset name has already been added before we actually tried to, or just to require, sorry, that the asset name has been added, basically. Sorry, I can try to explain that better in one moment. So yes, we want to know that the asset name does not already exist if we try to add it again. And then the very last thing that I'm going to do is just to, let me paste this in actually, is I'm going to define this new struct here where I can say this asset type memory A is equal to asset, and basically what I'm doing is I'm going to go ahead and use kind of the same struct up here to define and set the owner, the name. Since this asset is just being added, it's not going to be owned at this price. Then I'm going to set the price for the asset, and then it's at this point going to exist. Before, it should not have existed because we had not called this function yet. Then the very last two things that I'm going to do here are to set my assets with the asset ID equal to A, and then I would emit this add asset event. and I would pass along the message.sender, who is the manager in this case, as well as the asset type, which for now is just properties. All right, so next let's work on this transfer asset function. And I'm going to start out by just defining the parameters here. So from to, I'm going to have the name from memory, the asset type from memory. And this is also, of course, going to be a public function to be used in the next contract that we're going to write. Okay, so in this function, I'm going to start out with first a requirement, kind of similar to before, where only the asset manager can transfer assets. So I can kind of just use the same requirement from above to say only the asset manager can transfer assets. And then what I'm going to do is kind of some of the same things as before, where I am going to be able to get that asset ID. So here I define another unsigned integer of type asset, or called asset ID, passing in that name and the asset type to do some cryptographic hashing on that and return the asset ID back to me. I'm going to add a couple other requirements here. First, that the asset must actually exist. So before we trade or transfer it, we just add a requirement that it must exist, and that the owner of the asset is equal to the from address. So here, just making sure that the person actually trying to facilitate the transfer owns the property. Okay, and then the only other thing here that I want to do is to specify that the owner is the to address, or the owner will become the person with the to address. To specify this asset ID is equal to A, and then to omit that asset transfer event. And the asset transfer event, I think, had 4 different parameters here: the sender, the from, the to, the name of the asset, and the asset type. Sorry, is there a lot? I think I'm seeing in the comments that there's a lot of screen flickering. I'm not exactly sure what to do about that, but I apologize. I hope it's not too distracting. All right, so this is essentially everything that I have for this asset manager contract. That's going to allow me to both add new assets and transfer assets. I do see an error there on line 29, so I think I did mess something up. Oh. Owner, right? I want to have some way to distinguish between this owner and that owner. Okay, so then I should be good to go there, at least with this contract for now. The next thing to do, well, first what I should do, I want to go ahead and add a test. I'm also going to need to add a migration. So first, let's start with the migration. So I'm going to right click on this migrations directory, select to create a new migration, and basically these just go in sequential order. That's the order that the migrations will be run. So here I can define a new migration called deploy contracts. And within this migration, we basically just specify the name of the contracts that we want to migrate, and we use this JavaScript function to actually deploy the contracts on our Ethereum test network so that we can then use the contracts. So I'm really just going to copy this because the contract structure is pretty much always the same. I am going to migrate basically all of our contracts at one time, so I'm not going to do a separate migration for each one. So here I would need bank as the contract name. Also, I'm going to name the variable bank. So then similarly, I can add another line here for the asset manager. Go ahead and replace that there. Then I would just have a duplicate line here, or another line to call that deployer.deploy for the asset manager. So then I can basically run these migrations together. There's going to be one more contract that I'm going to write that I can add here as well. As I'm going along, it's also best practice just to make sure that everything is working as I expect. So I should definitely be periodically building my contracts and making sure that that's successful. Which it looks like it was. So let me open up the output and look at the output for the Azure Blockchain extension. So it looks like we're good to go there. I am not going to deploy the contracts just yet, but I am going to just take a break from looking at VS Code for a minute now to just introduce Ganache. Hopefully y'all have had the chance maybe to look at or explore with Ganache, but here it is. So this is the Ganache UI, and it just starts out with this menu where I can go ahead and add a new workspace. So that is the option I encourage you to use. And I do see a question, which language are you writing in? So I am writing in Solidity. I shared the information for that earlier at Paul 29, but here you go, is the Solidity docs over there. All right, so in Ganache, I'm going to start out by creating a new workspace. Sometimes it takes a minute and it's loading. All right, and now I get this white screen, which is not great. Hold on, let me try to quit and restart Ganache. Hold, please. And maybe let me at first try to at least go to a new workspace, and hopefully this works fine. Okay, so this works fine. Let me go cancel workspace. Yeah, that's fine. We can go ahead and use this. So this is going to be called cool. And here from the workspace, I'm going to choose to add a project. And this opens a dialog. Y'all can't see it, but it should just be a dialog to my file system where I can navigate to the project that I'm working on, the Solidity project that I'm working on, and link the Truffle Config file over to this project. So let's go ahead and add the project for now. Or sorry, it's already added, so we can save and restart. I do want to make sure, I think by default the port should be 7545. I might have changed my port. I think by default it is this, so don't worry about changing it, but I want to make sure I don't have a conflict with any other Ethereum clients running. So let's go ahead and save and restart. Cool. Okay, so for this project, this is kind of what the Ganache UI default view gives you here. You can see that there are a list of 10 addresses, which are going to be the different addresses that we're using to basically facilitate the transaction. So I'm going to be showing how to do that, but they get a test amount of Ether, and that Ether is going to be used as we're creating different transactions and calling events and such. You'll see that right now the transaction count for all of these is 0. I could also get the private key for each of these accounts. Of course, this is all for development purposes. The same goes for the mnemonic. The mnemonic is how you would access your wallet here with all the different accounts and their private keys. It's very important for a real life scenario to get this private, to keep this private, because anyone that has access to this can just basically take hold of your wallet and have all of your money. So then here we're going to kind of start to explore the different options that we have here. You'll see that it has all my contracts listed, that they have not been deployed. I've basically just built them so far, but I can't do anything with them yet. And then you'll see a lot of different assets and logs here, which are pretty helpful. Basically with Ganache CLI, you only see the logs. So it's really nice to be able to get this kind of UI view around your blockchain for now. So I think that's the important thing to show. I'm going to keep this open and kind of go back to VS Code now and continue working on the contracts. And we're going to be able to see how to better interact with the Ganache blockchain here. So going back to VS Code, there are more things that I want to do before I write that last contract. First is the Truffle Config .js and some changes that I want to make here. You'll notice that with a Truffle init, all of this config, there's lots of config, and that's helpful config, but we only really right now need to specify the development network that we're going to be using, and that is going to be using port 7545. So let me go ahead and change that. And I think everything else, at least right now, should be fine. Later, I am going to want to uncomment these items as I am going to be deploying to Azure Blockchain Service and to Infura, for example. So let me just go ahead and right click on this asset manager contract again, and let's just try to build the contracts and now see what happens. We've already built them, so it shouldn't be anything surprising. Cool. And then what about now if we deploy the contracts? And so here, let's try to do a deploy to our Ganache server running on 7545. And at Fox Rayman, Pragma 0.5 to 0.7 is too large of a spread. I would do 0.68 to 0.7. Yeah, let's definitely try that. I've tried out a lot of different spreads. I think that it's eventually going to be unhappy somewhere, probably in Azure Blockchain Service, but we can definitely try that. All right, so I can see the output here from that deploy. And now let's also switch back over to Ganache. And you'll see that just from deploying these contracts that I have these additional blocks here. So I kind of just had this initial block that was created, and now I should have these other blocks that were created as a result of a contract creation from those contracts now being created. And each of these should be the same contract creation for each of our contracts. The transaction page breaks that down a little bit more, where basically I can kind of see the contents of the blocks and see these transactions listed just with more detail initially, which is helpful to kind of understand what's coming here. I can see now also that my contracts have been deployed. And if I were to click on a particular contract, I can just see some information about it. That's not super helpful for now, but basically I think I can just see the address of the manager, which should be the same address here. You'll notice that the transaction count for this first address, our manager or banker, are basically the one who is having all the power, the only person in this game right now. They are making all the transactions. And you'll also notice that they have some amount of Ether that was decremented from the account. So that's about it for now. We don't have any events because we haven't actually called any of those functions to list events here, so we should try to go ahead and do that now. So let me switch back over to VS Code. And in addition to the bank test, I definitely want to add a test for the asset manager. Oops. So let's say asset manager.js. And at least for now, I'm just going to go ahead and copy over the test code just momentarily. Okay. Cool. So for this asset manager test, here I'm just basically doing the bare minimum of testing that I can. It could use a lot more, but here I'm basically just deploying the asset manager contract so it's available within this test context. I am testing the add asset function, where here I pass in the name of the asset type, which is a property, the price of the asset, and I think the owner here, which is account 0, which is our manager and all that. And then here I can do some assertion that we confirm that this event was emitted, and then we should be able to see that event being triggered in our blockchain as well. And kind of the same deal here with the transfer asset function that we're calling. From the transfer asset function, we pass in account 0, who is basically the owner, the banker again, who can transfer this over to the first account and then specify information about that asset type. And then on the last line here, I've confirmed that this event was emitted. So that is the basics of this test. What I'd like to do now is at least just run the test that we have before we get into the last contract. So I know that initially running these tests, I'm going to get some problems, and we can see why. So let's open up the terminal. Make sure that I'm at the right directory. So I'm going to just try a Truffle test to get started with. After a sip of coffee. Okay, so Truffle test, and it should fail because I have not actually imported this npm package. Oh wait, don't do that. And you'll notice that before, again, when I created this project with the Blockchain Development Kit, I had that nice package.json file. I do not have that here, so let's go ahead and add that new file, right? Not under tests though. Is that better? I can't always tell where we're adding these. Okay, hopefully I can just move it. Package.json. Yes, move that. Okay, so I'm going to start out with this blank file, but now let's go ahead and add the contents that we just need for traditional package.json file. I'm going to define the name, version, and some dependencies. So right now, the only dependency that I need is the Truffle assertions package. So I can go ahead and do an npm install from the terminal. To be sure that I am installing these two dependencies for now. Okay, I think we're good here. I get a couple warnings. Oh, cannot find module Truffle assertions. That is from this latest call, right? Did I spell something wrong? Nope. Let me double check. So going back over to the test, require Truffle assertions. I'm using Truffle assertions. I guess I should also kind of double check the version about Truffle assertions. I really just made this code last night, so I don't think the version should be different than what I was thinking, but let's see. Okay, maybe everything's fine. I don't know exactly what that error was about. Okay, cool. Truffle works for you with node 12, and my machine only works with 10. They must have updated. Yeah, at Fox3, man, I'm not sure either, because again, I was just using this extension and my node version was fine at 12. Cool, so now I'm at least just running the two different tests that I have for the asset manager and the bank. And if I switch back over to Ganache, I should be able to see these events. For some reason, they are encoded events, so I can't see what's happening, but there should be basically an event for every function that I ran that called an event. So for example, this one, well, it's really hard to tell because we can't see that detail here. Let me go to the transactions page and see what else we can find out. So these should have been new transactions added as well. And it is an encoded event, so it's a little bit hard to understand what's going on here. All right, well, we will continue to explore this a little bit more. To see rich data, link a Truffle project containing the contract that emits this event, which I did, right? I wonder, let's maybe try to restart it or something. All right. That's a little bit peculiar. Cool. And then I think because those events are encoded, I do not see them showing up here under the events for, say, the asset manager contract in particular. I really do like this view. I think when everything comes together really nicely, the contracts view, because it does bring together what's happening with this contract in particular by seeing the transactions that have been running on this contract, and also by seeing the events that might have been emitted as well. So kind of cool. I sometimes just spend time exploring here and trying to see how all this is working together more. Still, when I go back to the accounts page, you'll notice that I'm basically only still using that first account here. I have 24 transactions with that first account, but no other accounts, so we should change that. Okay, let me go back over to VS Code. And before I go on any further, let's see the smart contract interaction page, not right now. I'm also going to try, I'm really going to try to get that page back up. I wonder if I can do something like reload my extension. Maybe I can disable it temporarily and then reload it. And I'm doing all this, oh wait, oh, I have to enable it, just to try to see if I can get that smart contract UI page to open up so we can interact with things a little bit better. Then we want to enable you again. That should be fine. Okay. Not quite yet. Okay, let me keep that up in the background and keep going, at least for now. So I'm going to pause and look at the questions for now. So Daryl Challenger, in this contract, do the players involved in the transfer pay the gas, or is it the banker? Also, is the banker always player one? Yeah, great questions. And I think this will come together a little bit more in the last contract that I'll show. But the banker is always player one, like you said, our account 0, and the players will be the other addresses that we're going to add. And we're going to enforce rules in the banker contract that say that there can be no more than 6 players in a game. There needs to be at least 2 players in a game. So we're going to start to see the ways that we can basically interact with these different addresses and players, I guess, as we should refer to them. And they will also have to pay a certain amount of gas for the transactions that they are responsible for. So for example, when the banker, who has been making all the transactions for now, has been seeing that ether decrease. If the player 1 was to then pay money to player 2, you would see that they also kind of incur some gas cost as well. All right, so back over to VS Code. Let's go ahead and create a new file called banker.solution. And I think for this one as well, let me go ahead. I'm just going to copy over the code and we can just talk through everything, hopefully. I have to admit, I'm going a little bit slower on some of this than I thought I would. So let's try to just kind of talk through what's going on in this banker contract. Oops, I copied over the wrong thing real quick. Okay, so this looks better. And someone had also mentioned, right, let's try out changing the Solidity version before I forget to do that anymore. So we can try like between 0.68 and 0.70. I think that will be fine here, but maybe not again when we deploy. So what I'm going to start out by doing in this banker contract is importing a couple other contracts. That's going to be importing the bank contract and importing that asset manager contract as well. And then I define the contract name. Here I'm specifying the address of the banker. I am creating a new state variable to represent the bank, also to represent the asset manager. I create this enum to describe and define the pieces for the game. So I mentioned earlier that all the pieces for the game that we're using are cryptocurrency themed. So you can see that we have pieces called Bitcoin, Ethereum, Monero, so on. Then I create a new struct for the player. And to define the player, they are going to have an address, a name that they can define, some kind of string name to identify them. Bool taken is going to describe whether or not, I think the piece that they have is taken or available, and then here they can specify the piece. Or sorry, I think it's actually whether the name is taken or not. When we want to make sure that basically everyone has a unique name as well as a unique piece there. Then I would create this mapping here of the names from a string to a Boolean. So then we can, confirm whether or not the name has been taken or not. I create another mapping between the address of the player and the actual player struct here. Then I'm going to define a new array of public players, so then we can be able to add, again, up to 6 players for a particular game. There are different events here for determining whether or not the game has started, so we're going to emit these events when we want to start and stop the game. There is an event to say whether or not a player has joined, and then other Boolean events to kind of change the state of whether or not, and indicate whether or not the game has started and ended. In our constructor, this constructor is a little bit more involved than the other constructors we saw, where I think in the other constructors we're basically just setting up a role in particular to say that, the role of the message.sender is the mentor or the asset manager. Here we're still doing some of those role definings, where the banker is the message.sender. The bank, here we just call the new bank to kind of create a new instance of that bank contract. Then what we want to do is to just mint a large amount of coins, Blockopoly coins, to our banker, create a new instance of the asset manager, and then we go ahead and publish properties. So we're going to do all of these actions when this contract is created. The only one we haven't seen yet is publish properties. So for publish properties here, we want to add all of those different assets. So here I'm using that asset manager to call up these different functions to create our different properties. And these represent all of our Microsoft Reactors around the world. They're all type property, they all have the same price, and they are all owned by the banker. So then there is the start game function. here we are defining some rules that only the banker can start the game, that the game must not be started before calling the start game function. We are requiring that there must be at least 2 players for the game. We also then, when we start the game, do some minting to each of the players. So each of the players will start out with 1,000 Blockopoly bucks. And then we change this bool value of started to true, and finally emit the game started event. So kind of all that is involved with starting a game. There is the different requirements that we do to say that only the maker can start the game. There must be this amount of players at least in the game, and here's some money to get you started with. When we stop the game, similarly, only the banker can stop the game. The banker has all the power in this game. We require that you cannot stop an unstarted game, and then you can not stop a game after a game's already ended. And then we update the state a little bit more to say that the ended Boolean value is true and emit this game stopped function. And I think just 2 more functions to talk through, but this one is really just to allow players to join the game with a unique name, with a unique piece, and allow up to 6 players to join the game. The by property function, what we're doing here is basically just allowing a name to be passed in to be able to buy that property. So we can basically just define any of these names that we've already defined here. So if we pass in any of those reactor names, we should then be able to buy the property if the game is started, as well as if these 2 lines were basically describing if the property is not already owned, and if the player can afford the property. So those are the 2 things that we are going to require. Additionally, the last part of this function to actually be able to buy the property after going through the proper validation steps is to ensure that we can send the money. So from the owner, I'm probably going to have to look back at that function definition to remember the parameters, but I think we're saying, so send the money from the owner to the sender, and then specify the price, which the price is just 100 for all these properties. And then we would use the asset manager contract to call the transfer asset function, defining the new owner, the message.sender, the name of the property, and the property type. So that is pretty much everything. I did go through this kind of fast, so of course, like, go through this kind of in your own time to understand what's happening a little bit better here. The key idea is we're just trying to define a lot of the gameplay rules, and define what is going to be allowed. So I do have to fix one quick error here. I think I forgot to define that function before. 1 second. So in the asset manager class, I'm just going to go ahead and add this function in. So this get owner function is just going to return the address of the owner who owns a particular property, basically. Hopefully that should be good now. I think it'll just take a minute. Let me take a moment to answer some more questions over here. So I do see a question from Ron Miss. If blockchain causes so much data duplication, why do we have to use it? So I'm assuming that you're talking about the data duplication that we're actually seeing in Ganache, with seeing kind of a lot of information just from the contracts being deployed, migrated from running our test, from all of that. I would say that at least the important thing here is, understanding that this is a development environment. And I think this is kind of helping to do a couple things. First is just to ensure that have another layer of security and confidence that your contracts are working as expected, that you are firing the right events, that you're seeing the right level of transactions. I agree, it probably is a little bit much. You can see I haven't even really done that many actions, at least from my perspective, right? But we've already run 24 transactions. So it does start to add up. I think the idea is that by the time I'm actually really confident in my application and my contracts and ready to deploy them, by that point, it should be when the application is ready to go. So I would really only kind of be focusing on the core events that are happening and being added as transactions and blocks to my blockchain. So by the time this is kind of ready to go and out of this development phase, you should really only be kind of seeing the events that you care about. I hope that helps. So let me go back over to VS Code. There are probably going to be 2 more code changes that I want to make, and then we're going to get into deploying to the cloud. And that is going to be first in my migrations. Let's go ahead and just add a new file here. So this is going to be 3 deploy contracts.js. Contracts our migrations all have the same format. So let me just change everything here quickly. And we can get rid of that. And then I want to add in a test. And the test, and I mean, even the code for the banker is the most involved since we're importing and using other contracts. It's important just to kind of make sure that everything is working as we expect. So this test is a little bit longer, but still not even complete. I think there is still so much that can be done to further kind of test and build out this game. The tests that we have, at least for now, are testing joining and starting a game, that all that works as expected. So after deploying the function, we can test out the join and the start game functions. And then we also have some testing around being able to buy the property. So making sure that the property is available, that you can buy the property if you go, that you can buy the property if it's available, basically, and it's not owned. So that is the core test that we have for now. So let me just go ahead and now make sure that all of this still compiles. And I should actually right click on this, and let's go ahead and use the Blockchain Development Kit to build the contracts. I did run into an error. Oh, okay. This is helpful. So these are the types of errors that I run into. If you can see that, it's describing here an error that Truffle is currently using the Solidity compiler 0.5.12, but one or more contracts specify Pragma Solidity 0.6.8 to 0.7.0. So there is often some compiler problems that I get, which is why I kind of just leave the range a little bit more broad. So let's go ahead and try that again and see what happens. Okay, and that looked to be successful. Fox Rayman, I do see your comment here. Specify 0.6.8 in the Truffle config. Is there any pre-commented place where we can define that in the Truffle config? Yes. Okay, yeah, let's try that here. I don't know if I need any more of these settings. Let's try that and see what happens, actually. So then you're saying I should probably be able to say greater than or equal to 6.8 and less than. Oh, okay. Let's try it and see what happens. I see a no. All right, so my contracts should be building now. I've just selected to build them again. All right, so that seems to have worked. Nice. Thank you for that, Fox3Man. Okay, so then we're good to go there. Let's go ahead and then deploy this contract. We're going to deploy to the development environment again. And we should only be running the new migrations now, I think. Oh, it is doing some rerunning of migrations. And that was successful. Still can't see this. Okay, so we have done that. I think the last thing that I want to do is just be able to run the test, at least for now, and make sure that that new test file for the banker contract is working as expected. All right, and all those tests pass, so then we are good to go there. So I think probably one of the last things that I want to do, or the last couple things that I want to do, are to try out actually deploying this to the Azure Blockchain service. So switching over, if I go over to my browser, I have actually gone ahead and created a Azure Blockchain Service member. So I kind of set this up in advance because it does take a little bit of time to do. I think when I created this morning, it probably took about 10 minutes, and we don't want to sit and wait for that now. But just to kind of give you a heads up, that's what you need to do and kind of just wait for and be patient for. So I have to find a resource group. This resource group is kind of just going to hold all of the different Azure resources that I'm using that are all related to this Blockopoly project. So I think for now, there's nothing else in this resource group except for my Azure Blockchain Service member. You can see the subscription that I'm using. By default, the Azure Blockchain Service works with the Quorum ledger as the protocol here. I think, which is pretty much just the standard, and then I think that's the only ledger that the Azure Blockchain Service provides. I'm just using the basic tier. This is helpful to understand. I know that folks are always interested in the pricing, so I'm just using kind of the basic development environment, which is still not very cheap, but I think just for testing purposes, I am just going to create something for now. And this is just the estimated cost per month, basically based on your usage. So it could very well be less than this, but it's at least important to understand the different pricing structures and what you could be charged. If you're kind of just like me and just exploring and testing this out, definitely go with the basic, and just kind of when you're done with testing out this Azure Blockchain Service, I would definitely go ahead and clean everything up. Always a good rule of practice to clean everything up that you're not using so that you're not being charged for things and not being surprised. So that's kind of everything that I want to show here for now. So let's go ahead and deploy the contract to this Azure Blockchain Service and then see what happens. Actually, I did lie. One thing I didn't call out was the consortium. So I did create a consortium called Blockopoly within the Quorum ledger. And basically just creating this consortium is going to allow me to basically manage who is part of my own blockchain network for this Blockopoly game. So even from Azure Blockchain Service, I can do things like invite members from the consortium, so I can invite other people that I want to participate on my network. I think that's one of the cool benefits about Azure Blockchain Service, is that this is a place where you can kind of manage who has access, what type of access that they have, like what role that they're able to assume on the network, things like that. And then there's also different data that we can explore here, similar to kind of how we saw in the Ganache Ui, but you can see the blocks that are being used, the transactions that are being made, the number of transactions, the requests. So this is kind of a good place to come and do some extra monitoring of your blockchain network and just to kind of understand what's happening at more of a high level here. And I do see a question, can we pay with Ether? And unfortunately, you cannot, not right now at least. Okay, so let's go down to, I'm down in the bottom here in the blockchain network section. I have the local service, and I want to go ahead and, let's go ahead and connect to a network. And you'll see this menu pop up. So I want to go ahead and connect to an Azure Blockchain service. I see all of my available subscriptions here. I do have a resource group, and I have a Blockopoly consortium. So I've already set all this up, but also it's good to call out that you can create all of that. You can create a new Azure Blockchain service member from within VS Code. That is something else that's just a nice perk of the extension. And I think the whole point of the extension is to allow you to kind of stay in the IDE and do a lot of work from there without kind of having to switch around and go to the portal. Although eventually you're going to want to go to the portal. So here, basically, I just see that my blockchain network was added. Hooray. And what I'm going to do is to go ahead and now let's deploy contracts again. But you'll notice that I do see this Azure Blockchain Service deployment option added here. And now I have the option to either generate a mnemonic, to paste a new mnemonic, or to use another mnemonic that I have saved previously. Let's go ahead and generate a mnemonic. And I'm gonna put that, sorry, I guess you can't see what's happening. I'm creating the file where my mnemonic is gonna be stored. I am thinking about where to put this because of course I want it to probably just, not be part of this project that I'm using. For now, I think it's okay. I am actually just going to put it on there so I can access it when I need it. But it is very important to keep this safe in a real production environment. So I went ahead and saved that. I should see that mnemonic file that was added here. The blockopoly.env over here. And then in the very bottom of my screen, I can see that the contract is actually being deployed. And I can start to see the status of the deployment. It might take a few minutes down here in the bottom. Cool, some more commands are executing. We're doing the deployment of the bank, deployment of the asset manager, and then the banker should be next. Cool. And I'm just waiting for that to finish. All right, so now I can see in this last line here that the deploy did in fact succeed. So I can go back to Azure Blockchain Service and basically see what's changed here as well. Oops, there we go. And I should see, yeah, I think I at least see a spike in transactions from right now from the deployment of the 4 contracts that I have. So that looks to be accurate. Kind of seeing the same thing in pendings transactions, and that there was also a surge in request. So it's just helpful again here to kind of see and be able to get that overview of what's happening on my blockchain. Let's see. That's probably all I'm gonna show on here right now. There's not really much more interesting things to show at the moment. I think the other thing would be, the really big thing is around kind of inviting other folks to participate on your consortium. But I kind of just wanted to highlight how you can at least get started with that deployment to Azure Blockchain Service. And once you have everything set up, it's pretty easy and straightforward to do that directly from the Blockchain Development Kit. Lastly, I want to explore adding another new network. Let's connect to a network. So we've tried out the local service, the Azure Blockchain service. Blockchain Data Manager could be somewhere else that we want to deploy to if we do actually want to deploy more of the data from our blockchain. So kind of thinking about similar to what we saw in Ganache, I can deploy that up to the cloud so then I can see more in-depth environment about all the data that's being transferred and the events that are happening. I could also use Infura service. And let me hop over to the browser and we can actually just check out Infura. If you go to infura.io, there's the link there. But this is a really nice way and just another option where you can deploy to the Ethereum network. It's free to get started. There are a bunch of different networks that you can deploy to. So either kind of the main Ethereum network, or there's other test networks that you can deploy to as well. This is a very popular network that's used by lots of different companies and services here. And typically what you can do is kind of see more detail here about what's happening on your blockchain. So you can see the different method calls that are happening to basically get a sense of what's happening at a higher level on your blockchain. You can see the bandwidth usage by these different methods. More information about the calls and so on. So this is kind of another alternative, I guess, to Azure Blockchain Service where you can get more of that high level overview and more kind of logging and diagnostics about what's happening on your blockchain. So if I go back over to VS Code, from here, from VS Code, I can just create a new Infura project. So I could call this Blockopoly, for example. Then I can select whether I want this project to be public or private. I'm going to make it public for now. And then, cool, I should already have been previously authenticated to this Infura service, but if you're not, it would ask you to go ahead and authenticate and provide your credentials here. But it can just be added as another blockchain network. And then I can easily go ahead and right click to deploy my contracts again. And there are a few different options that come up here. So the main net, the main Ethereum network, and then there's other networks as well. To be honest, I don't remember all of these. I do want to make sure that I am deploying to the right network, at least the testing and development network. So let me remember which one that is. And the docs for Infura help explain all of this, basically. I can go back to the browser. But I believe what I do want here is the Rinkeby network, but let me confirm that. Okay, so here actually at Choose a Network, here is more of at least a list of all of the networks that are available. Yeah, I think it's Rinkeby. Let's see. Yeah, so Rinkeby is one of the test nets. So let's go ahead and start by deploying to there. Oh, there's a lot of information here about all the other public blockchains on Rinkeby, which is pretty cool. What happens if you pick the wrong network? Yeah, that is a good question. I mean, yeah, that is a good question. I think there is not so much bad that can happen right now. I mean, I've created all this for free. To sign up for this Infura account, I signed up for free. I didn't provide any payment information. So like nothing that bad will happen. Just again, as you're kind of testing out, I would just want to stick to one of those testing networks. And it's probably worth it to do a little bit more exploration about all of these different Ethereum networks to kind of find the right one for you. But I don't think there's not really much harm that can be done. What's cool here is that it is actually allowing me to enter a gas limit. I didn't talk much about gas in this session. I do have this default value here. I think that's 4 million, 4.7 million or something. That's maybe fine for now. The gas price is probably fine. I'm not going to do a lot with it. Similar to the Azure Blockchain service, I can choose to generate a mnemonic or even use the same mnemonic that I was using before. But yeah, I think also thinking about the networks, I'm curious just to try out different networks and kind of see what happens. But again, since there's not really any real fees or any sensitive information happening in this smart contract application so far, I don't really think much can go wrong. Oh, okay, so this is helpful. So my deployment did fail because I did not have sufficient funds. The upfront cost is this, and the sender's account only has 0. So my deployment did fail. All right, so this is actually helpful. And this is what I wonder if you actually are going to be like prevented from deploying to some networks because maybe you don't have real funds. But I thought that this should have been fine. Let's see. And I wonder if I can try to deploy again and make sure that I have sufficient funds. Balance 0 away, the upfront cost is this. So that should have been our gas price times the gas. All right, let me, can I try to redeploy this and have another increase of gas? Could also try a different network. Gas limit. Can use that same mnemonic. Okay, I'm going to try another deployment. After changing a couple things, after changing the amount of gas I have, I also was trying another network. Okay, so I am running into some other problems here. Try sending less gas or setting a higher network block limit if you are on a private or test client like Ganache. All right, and actually let me check in Ganache to see if we've seen anything change here. Which we should have. By now we should probably see a lot more transactions than before. Different events that are happening. I just can't tell exactly how much gas that I have left, I think is the problem with all of this. All right. So I think this would be something fun to look into that I'm probably going to stop looking into, at least for now, since I'm at about time, but definitely am going to be looking into this more because something went a little wonky here and I need to change the amount of gas that I'm sending. But that's also just kind of a good example to see that you need to have kind of enough gas or sufficient amount of gas to do all of these transactions that you want to run. I guess that's also something that's interesting about running on a service like Ganache right now. We're testing and doing all this developing and really kind of using up a lot of transactions at this time. So it's always just something to be aware of, because I think you will eventually run into these issues where you run out of gas and you kind of have to do something to either restart your server or either, change the amount of gas that you have available. So things like this happen and it's okay, essentially. Yeah, I think that's probably about where I'm going to stop today. Again, I am likely going to have feature sessions around kind of exploring more into these different cloud Ethereum networks that you can work with, and also work on kind of just building a UI around some of these apps. Since I am still not able to use the smart contract UI and actually call out these functions a little bit more, we're definitely going to work on building out some apps and kind of put more of a UI around this to make it a little bit more exciting, especially as I think about continuing to build out these contracts and being able to actually play this game and to have a nice UI to play that game. So that's kind of the next steps. I think that's it. Please let me know if you have any more questions. I'll be around for a few more minutes. Thank you all so much for joining me today. I was just saying, I don't think this demo was the smoothest. Sometimes things go wrong, and that's okay. That's all a part of development and learning. But there will be more sessions, so I'd love if you would connect with me. Let me know what else that y'all are interested in exploring, what other projects that you're interested in. Yeah, and I think that's it. Thank you for watching. Here is a link to the survey. We would really appreciate it if you just filled that out. It probably is going to take you about a minute. And that is all from me today. So I hope that you all have a lovely day, evening, afternoon, wherever you're joining from. And thank you. Goodbye.